ఒక్కసారి చూపించారు ఒకసారి
ఫోన్లో చూసుకో.
everyone. On behalf of the Mechanical Engineering Students Association MESA, I extend a truly warm welcome to our respected HOD sir, esteemed faculty, our distinguished keynote speaker, and all the enthusiastic students gathered here today. We are delighted to have you join us as we celebrate the spirit of innovation and learning that defines the Department of Mechanical Engineering. To officially start our proceedings and share a few words of guidance and encouragement, I now invite our respected faculty advisor, Dr. Sagi Ratnaprasad sir, onto the stage. Sir, please.
Good afternoon, everyone. Respected HOD, Mechanical Engineering, invited speaker, faculty members, and dear students. I once again welcome you all to the session organized by MESA on the title Mechanical Engineering in the Era of Industry 4.0. Innovations, Challenges, and Future Opportunities. So this is the theme for today's technical session. And so I'll take this opportunity to briefly introduce about MESA. So the MESA is the Mechanical Engineering Student Association, and it's fondly known as MESA. And it has been always a vibrant platform for the students to take the opportunity to learn how to lead, how to collaborate, and how to learn out of the classroom. And also, the main objective of the MESA is to bridge between the academic learning and the industrial requirements. To address this research or to address these gaps, so this year the MESA has come up with a calendar, so which is designed and focused on improving the technical competence, innovation, and professional development. So, in this, as a part of this MESA activities throughout this year, so we have lined up a series of guest lectures, hands-on workshops, design challenges, industrial visits, technical paper presentations from research scholars, and community research activities. And soon the calendar will be launched by our beloved HOD. And I believe these activities enhance the creativity, strengthen technical skills, increase competitive spirit, and build confidence among our students. And so also it will help them to prepare the demands of the rapidly evolving mechanical industry. And so I'll just talk about today's theme briefly. So Industry 4.0. So the world of mechanical engineering is undergoing a massive transformation. So the traditional design and manufacturing are now being refined through the digital integration. So combining IoT, AI, robotics, and automation. So for mechanical engineering, this means more opportunity to innovate, but also the responsibility to adapt, lead, and knowledge and the vision. So therefore, today's session is a step in the direction to enlighten, inspire, and equip our students to see themselves as the future innovators and as the leaders in the digital age. So the speaker will talk about how relevance to this particular topic. And I take this opportunity to sincerely thank our respected HOD and faculty members for their continuous encouragement and support. And also special thanks to our invited speaker for accepting our invitation and coming from a long distance to share his valuable experience on this today's thematic topic. And I also take this opportunity to wish and appreciate the MESA student team for their enthusiasm, creativity, and teamwork in organizing this event and planning an engaging activity calendar for the entire year. So I encourage all the students to actively participate in the upcoming MESA initiatives. So this will help you out to, or it will give the experience for the students, not only for your technical knowledge, but also it will help to how to lead the events and also improve your communication skills and also the teamwork skills. So with these words, I once again welcome you all to this thematic session, and I also wish all the very best for the new MESA team. Thank you so much.
Thank you, sir, for your motivating words and officially setting the tone for today's event. Next up is the moment that signifies a major step forward in our association, the official launch of our MESA website. This platform serves as a unified space showcasing our association's initiatives, achievements, and future plans. I now invite our respected head of the department, Dr. Dinesh Shetty, to officially unveil the new website. Sir, please. Thank you, sir. Now let's take a quick walkthrough of the website and explore all of its features. Starting with the home page, you'll find a brief overview of MESA and its core purpose. And the About section dives a little deeper, highlighting our objectives, vision, and what we aim to achieve as a student community. One of the most interesting part of this website is calendar tab, which gives a complete events plan right up till August next year, including the alumni talks, technical workshop, sports and farewell events, mock interviews, mock gate preparation sessions, and many more. The team section showcases the faces of MESA, our coordinators, our members, and everyone who keeps things running. Next is the gallery tab, which offers snapshots of our previous events, capturing spirit and energy of our department. Finally, the resources tab connects you to the useful academic portals like LMS, Central Library, and Records portal of IIT Palakkad. That brings us to the end of a short walkthrough of the MESA website. It truly reflects the efforts and teamwork of our department, and we hope it becomes a space where everyone stays connected and updated on the upcoming events. Now I would request our HOD, Mr. Dr. Dinesh Shetty, to say a few words and share his thoughts on this occasion.
Yeah. Good afternoon to all. Yeah, first of all, my hearty congratulations to MESA and the entire team for launching this beautiful website. Right. So as you could see, it is showcasing what they are going to do and then who are they. Right. So what kind of activities they are going to do in the future. So I very much appreciate the efforts what they have put in building up this entire thing. So nowadays the websites are no longer static pages, right? It is not just a platform to put the things there. So I hope that the MESA team will continue to update it, and also, as they mentioned, they are going to show the activities what they are going to do or the achievements and all the calendar, right? So that is, I hope that they are going to do it from the time to time, and then that will help, or that is going to show the face of MESA what they are going to do in the future. Right? I hope that the team is going to continue the same spirit, So whatever the support that is required from the department, always we are there to support and then increase whatever the resources you would like to have, we are happy to support and then extend the resources to you. Once again, I wholeheartedly congratulate the entire team and wishing you all the best for further activities. Thank you.
Thank you, sir. Your support and guidance are invaluable to us. Now, moving on to the most anticipated part of our program, we are honored to have with us our keynote speaker, a distinguished professional in the field of engineering and technology. It is now time to welcome our keynote speaker, Mr. D.R. Akshay, co-founder and CEO of MESA Engineering Services Private Limited. He holds a Master's in Embedded System Design from Manipal Institute of Technology and BE in Electrical and Electronics Engineering from RMS Institute of Technology. With over 16 years of expertise in companies such as Wipro, Ariston, Mr. Akshay now leads MESA, which collaborates with global leaders like Mercedes-Benz, Siemens, and Acme. He has authored 12 IEEE papers and holds 5 patents in the fields of AI, IoT, and embedded systems. MESA and IIT Palakkad are truly delighted to have Mr. Akshay with us today and share his insights and experiences. Please join me in warmly welcoming Mr. D.R. Akshay.
Good afternoon. Hope I am audible. Hello. Yeah. So I know it's been a sunny day and lunch has just been served. I just try to make it as interactive as possible so that you guys don't fall asleep. Trying to make it interactive. I would want to have more conversations than giving you a lecture, right? So feel free to stop me whenever you want. And let us have a conversation more than a static lecture. So myself, Akshay, as they already given a brief description about me. So I started off as a lecturer, frankly. I know I don't look like a lecturer, but yeah. So I have been teaching for 2 years, and even now I'm an adjunct professor in one of the colleges in Bangalore. So I like teaching, so that's the reason I try to give lectures or go back to college because that gives a way of interacting with people. So I love interacting with people. So I started off my career as lecturer, and then post that I moved into Wipro. From there I went to Schneider. So I've been into IIT most of my life. So where everything got triggered is in my previous organization, where we started working on IoT. So can anybody describe what is IoT? Can we have a mic that is circulating? I hope you guys have heard about IoT, right? Can at least raise your hands. Have you heard about IoT?
అసలు మస్తు అన్న చేతులు ఎత్తాయి కదా
So I was just trying to say that he has heard about IoT. Yeah. Yes, of course. IoT is nothing but Internet of Things, but he is just giving a little twist to IoT, which is IoT. So, IoT is too plain, so we are just adding another I in it. Primarily, we are working on industrial IoT, right? So, this was almost 5 6 back when we started working on IoT. What we used to do is, primarily, for example, look at this, the number of lights that we have. I don't think for every light we will have a switch, right? So we will have a centralized panel where you can control all these lights. So, and most of the time people forget, they don't switch off, they just walk out, the energy consumption will continue. So that's why in my previous organization, Aristom, which was later converted into ADAPT, what we did was we made sensors which are related to the light, only is there, lights turn off. Simple solution, nothing too complicated. So now that's when Vodafone came up to us. Said that you're already making the sensors that are going to the lights. Do a smart twist in it. Just remove the lights from it. Just give us the sensors and put it under the desk. So why? We asked because that was very new to us. So then we understood what they wanted to do is monitor their employees, right? So how long they are sitting, where are they sitting? They wanted to understand, for example, if I have a building capacity of 1,000, are all my 1,000 seats getting occupied? If not, then how much is getting occupied? So, by a thumb rule, more than 25% of the people are absent, either on sick leave or some vacation or something. So, for a 1,000 capacitor, seat capacity, can I fit in another 1,250 people? So that was their thought process. That's when we made the sensors and we put for them, and of course they did not give us an order. But the next building there was Barclays, a bank, very big bank. So they gave us 15,000 sensors. So we had to deploy, right? So but nobody had done at that scale. So 15,000 sensors, imagine reading every microsecond, the amount of data they will get. It was crazy. So we were not able to, we did not have technology. Our sales team, as always, goes to promise something to the customer, comes back to us, the R&D people, and say, I'm already sold, do something now. So that's where the trigger started. And then we did not know what technology to use, which sensor to use, which is the optimal sensor, how to do the communication. You can draw wires, 15,000 wires, imagine a complete building. It was impossible. We had to go the wireless way. So that's when we started working on Bluetooth. So we started working on Bluetooth and we made the sensors, we put it up for the customers, that started going, and then came the challenge of huge amount of data. And then came the challenge of data handling. So like this, one after the other, we kept solving, and we gave them a good solution that is working till date. So we got good revenues, but the management ate majority of the money and we got nothing from it. So that's when we thought, so in fact when we did that particular installation, we used Qualcomm chipset. So for doing the Bluetooth communication. And we had to use something called a mesh network. So mesh network basically enables you to connect huge number of sensors in a single network, get the information and then push to the cloud. So we work on some different idea technology and we try to implement it at the scale at which Qualcomm also had not tested. Even till date, if you go to Google and search Qualcomm and ADAPT, there is a case study that Qualcomm did on us because they themselves had not tested that particular chip at that scale. So in Chennai, we have one building where we installed 6,000 sensors in a single floor. So now, the biggest challenge was an Indian company trying to do at that scale, whereas there was European companies who were putting samples for the same customer, Barclays in Europe, and the system was failing. How? Because everything works at 2.4 gigahertz. That is the communication frequency over Wi-Fi as well as your phone Bluetooth. Now, what was happening when the sensors turned on? All the Wi-Fi was, basically getting overloaded, and the internet speed used to come down, and the employees were facing a lot of issues. But in our system, they never faced this issue. So now that's how we kept getting orders. We deployed it in Japan, we deployed it in Singapore, we deployed it in different parts of the world for them. And then as time passed, as I said, the same issue came. A lot of orders came in, the managed to get good number of revenue, but we got nothing. So that's when we thought, okay, now let us try to use the technology that we have developed and the experience that we have gained, and let us try to do something different. That's when the idea of Invest came in, and we started working on industrial IoT. So how do we bring in technology into industries that can help them? So that's where we started thinking. So we started in 2019, the golden year, where the very week before COVID hit us. So we started, and I went and told my friends and family that I've started a company. The very next week there was a shutdown. So we had a issue with COVID. So now we did not know how to survive. I already resigned from my previous job. I started a company. So we had to survive. But yeah, so COVID gave us 2 solid years to do the research. So, thanks to my dad and my colleagues who blindly resigned from their jobs and joined me for the new venture. So we all got 2 solid years to sit at home and develop something. And from 2019 onwards, we are solidly focusing on bringing IoT into industries and try to see how do we contribute to industry in a way that actually matters. So that is what we were trying to do. And we were one of the companies which had done large scale deployments. We knew, we had seen, we had faced issues at scales which people had not even thought of. And so whenever I know a few people said you've heard of IoT, but the same thing if you talk to your electronics guys or CS, maybe the number of people who have heard of it will be more. But the thing is now if you see in YouTube or anywhere. So now, whenever you talk about IoT, people use Raspberry Pi. I'm sure you've heard of Raspberry Pi? No? So microcontrollers and ESP32s. So people take these samples and then they try to write a simple program which your Claude or ChatGPT is giving, and they say we are IoT ready. I know how to do IoT products. So that's what people basically claim. So now the problem is these words are development words. You cannot bring it into industry and expect it to work for a longer time. These are the biggest issues. So now, when we talk about scales like 10 numbers, 20 numbers, as an experiment, definitely you can do. But when you look at scales like 500, 1000, 2000, then everything has to be taught in a different way altogether. It just does not work out. So now that's where we had confidence and expertise, and we wanted to do that. So now, what are the major problems we started addressing? For example, any industry for that matter, what is the core thing that any industry looks at is profitability. So how can you improve the profitability of an industry? First, you need to reduce the unplanned downtime. Right? I don't even know whether my machine is going to run today. I go to the factory floor today, I switch it on. Whether it's going to run or not, if I don't know, then how am I going to plan my production? Not possible. That is the first thing. Second thing is, there is one very good saying: if you don't have data, basically you are blind and deaf, right? So if I don't even know who is going to sit in the production line and how much production am I going to do today, what am I going to plan? Right? So now there is no real-time visualization of how much product I can produce today, at what productivity, who is going to do it, what is the process. Like for example, maybe we need to manufacture this table. Who is going to do the packing? What dimensions? And then what is the process of assembly? Who is going to do the QC? Who is going to do the packing? So what is the step? I can't do the packing first and then start to do the assembly, right? So now there must be a process. If I don't even have a visualization of what is the process, how are you going to improve the efficiency? So that is the second step. Third is, of course, optimizing your production process. So once you know this is the process that I am basically working on, and then you realize which is the bottleneck, which process is taking the maximum time, then you can come back saying that, okay, now this is how I can optimize this part of the process, and then you improve the efficiency. And last, of course, is in-time servicing and spare parts stock. So this is a very interesting thing that I understood from my customer. So in very large industries, for example, Adani, ITC, people basically buy stocks on a yearly, annual budget. So maybe 100 crores is budgeted today. For 100 crores worth of stock, they are buying irrespective of any failure. Why? The plant head is going to be responsible for ensuring there is no unplanned downtime. So if there is a downtime and then you don't have stock, then the impact is huge. So what he will do, he will order more irrespective of whether it is needed or not. Right? So now, but how much stock to be bought, nobody knows. So once I have a data and then I realize now this is the kind of failure that we are looking at, then I can basically plan as to what stock I need. So now this is the 4 major sectors that we are basically trying to address. And that's how we are trying to help the customer improve their profitability. Of course, these are the problems which I basically explained already. First is limited monitoring. So hardly most of the industries, even at scales of Reliance and Adani, don't have entire monitoring of the entire plant. And next is no real-time data, limited visibility of machine and process information, and difficult to maximize productivity without the right information. Right? So these are the major problems that people are facing. Now, how are we trying to solve this? We have developed a set of hardware as well as software. I'll give you a demonstration of both hardware and software that we have basically developed. So first is of course the vibration sensors. So now, again, very interestingly, if you see vibration sensor, even if you just Google vibration sensor now, you get vibration sensor starting from ₹150. So now you take that, a lot of people are there. So, I had very interestingly, I got a call from one of my counterpart in US. He said, there is some company in US giving you a vibration sensor for $4. I'm going to take that and I'm going to put it on my generator and I'm going to tell whether it is healthy or not healthy. I said, go do it, all this. So now you must understand which kind of sensor you need to use where. Right? So if you have loose motion, you don't take those. Right? So it is the same thing. You need to use the right medicine for the right problem. You need to use the right equipment to identify the right issue. So now if you go to a doctor and with cold and cough and he is trying to do an ECG, it makes absolutely no sense. Right? So now that is where we are trying to educate our customers saying that use the right sensors first of all. And then you will get the right result. So now that's where we started working on vibration sensors. We have series of vibration sensors based on the kind of equipment that we are trying to monitor. Next comes machine analyzer. So now we have brought down the size of machine analyzers to this much. Of course, this is a little dirty because I just got it back from the site yesterday. So this is a machine analyzer that we have created. So if you input this, the cheapest option from Emerson would cost you somewhere around 18 to 20 lakhs. What we are trying to do is bring it down to 2 lakhs. Right? So now, what does this do? So you can connect different sensors to it. And then if the engineer goes to the near the machine, you place the sensor on the machine, you will be able to collect data using this and try to analyze the machine on the spot. So using your mobile phone or tab or of course laptop is going to be difficult at the site. So either in the phone or tab you will be able to do the complete analysis. So of course as you progress in your semesters you will understand FFT and a lot of other analysis techniques using which you will be able to analyze different points. So which briefly I will show how it looks like. So that is what we did. Next comes the third is the protocol converters we have in hardware. So what is protocol converters to most of your automated factories like food processing plants. So it's huge. So I think I just if I have the video, I'll show you how Coca-Cola is manufactured. So we have gone to that plant. Majority is automated. From the time the chemical is getting mixed, it is getting bottled. Most of it is automated, right? But the top management does not have a visualization of what's happening. So now the biggest problem is, say suppose you set up one assembly line, which runs into few crores. So they use Siemens equipment to do the entire setup. So maybe after a year or so, they try to put a new plant. So now Siemens say they Siemens, let us Honeywell. So somebody else puts up a PLC. The issue is that line 2 does not talk to line 1 because it's from two different manufacturers. So now unless I get all the data to my centralized dashboard, how will I visualize it? How will I process it? How will I optimize the process? So now that's where we have bought in protocol converters which has GSM built into it. You just plug to your any existing PLCs, you will be able to extract data and you will be able to process it in the cloud. Next is cloud DATs. What we realized with the customer is that each time we go and speak to the customer, different customers, for example, steel plant, steel plant, food processing plant, so different cement. So each time we talk to different people, the kind of parameters I want to measure is becoming different. So now sometimes pressure, sometimes temperature, sometimes rain, sometimes vibration, things keep changing. So now what we have done a cloud DAQ where you can adjust the sampling frequency and you can connect any sensor to it. It basically digitizes the information and pushes the information to the cloud for further analysis. So now, of course, once we finish the hardware, the next thing is software. So we started creating software where you can visualize and analyze and give you a glimpse of how it basically looks like. And then, of course, a mobile analyzing app, so which you can install in any Android phone or tab, where you can do your FFTs, FRs, and everything you can do. And now, the biggest challenge again coming back here is your data. Now, in the previous case, when I talked about occupancy analysis, the data was way lesser. Even though at that point of day it was high, today we are getting somewhere around 1.5 terabytes of data. So I showed you that we are monitoring close to 22,000 machines. So imagine how will you analyze so many machines in a single day? Not possible. So churning out 1.5 terabytes of data and trying to analyze which is good, bad, ugly, not possible. So now that we started looking at ML engine, and this is where we wanted to also associate with IT partner to see how we can collaborate and try to make this engine. So that's where we are looking towards. So this, of course, few sensors. Most of it I have basically explained. So I'll not get into the depth of each hardware unless you guys are interested in understanding it. So I'll just go into case studies which will be more interesting. This specific site is ITC server space. It is in Bangalore. So now majority of the servers of ITC is there. Now what is the problem statement here? The problem statement is next to the building there is a excavation going on. And each time the drilling starts in the next site, the servers are drilling inside the place. So now why? Because the vibration is so high that the servers started tripping. So now ITC wants to put a case against them. So now to put a case against them, they need data. And we are providing the data. So now what we are doing, so now can I put again? So coming back now, try to present the problem statement. So now all I need to do is try to measure the structural vibration and give an input to both ITC and also alert to the next guy saying that you need to do something about this, right? So can I put a piezo sensor here? So I'm not sure. I don't know whether you guys have heard and know the difference between a MEMS and piezo sensor. Okay. So now, okay, there are different variants of vibration sensor or accelerometers that are available. So based on how deep your pocket is, the better ones that you get. So now here, you cannot just pick a random 150 rupees sensor and put it here and try to expect it to work. So of course it is going to give you values, and who knows what the values are. So neither the ITC guy will not know. ITC server guy, how will he know what should be the right value? So mechanical engineers such as yourself has to come up and give the right information. We need to know which sensor is the right sensor to be used. Second, which is the right place to be used. Right? So, for this, I'll just give a very small story. So now, apparently, few decades back, there was a huge ship, so which always had an issue, right? So now it was coming for servicing back again and again and again. So the shipping company spent more than few millions to get it repaired, but it was not getting repaired. So again it was coming. So next somebody suggested a very old man, and then they requested him to come down and then try to look at what's happening. He came and then he did a very small work of putting one bolt at one place. Once that was done, it never had a service issue. And he gave a bill of $200,000. And then the company said, you didn't even spend 30 minutes on it. What should I pay you $200,000? He said, it is not about the 30 minutes that I spent now. It is about my decades of knowledge that I have, which help you solve inequalities. Right? Just you must know where to put. Right? That is the most important thing. Where to put, what to put is very important. Once these two are figured out, of course the results will be better. Right? So now here the case is very simple. You have put vibration sensors on structure, and you are trying to monitor when the vibration goes up, alert both ITC people and also the people who are doing the construction. This is another beautiful case. I was explaining one of the case earlier today. So now this is one of the paper plants in India. So what is the issue? Before the pulp is basically created for making papers, they just get grinded. So now for grinding, there is a huge gearbox that is connected where the drive motor is connected to it. So now what happened on a specific unique day is, I don't know what got stuck or what happened that day. The vibration went up very high at late night 12:30, 12:40. Fortunately, touchwood, our system basically got captured that signal and alerted the customer also. So we have both SMS and email alert. The alert has gone, but by the time they actually saw that and went ahead, got all the permissions and came to the site, it had already worked. So now this specific gearbox costs around 1.5 crores and requires 6 months of upgrade. Now, pulp, before pulp, this one has to get grinded. That is the first step in your factory. And if the grinding machine is stopped, then the plant is stopped. Right? So now this is where it comes to the important point of identifying the issue at right time and taking action. So now at least we did the first part of identifying. Action was not in our control, but this happened there. And second is one more example in the same site. Because of the delay in action, I should have the photos. I'll try to show you the photo. The entire shaft just it's like it got twisted like the way you twist a towel and it just broke and it was just thrown around 2 to 3 meters away. So that's how dangerous things can get if you don't identify issues on time and try to rectify. So now those two examples I specifically to highlight the vibration sensors that we had basically developed. So now this is another unique problem that we started working for Mercedes. This was our lifeline. 2019 when we did not have any job, Mercedes gave us a small project to basically work on, which helped us survive for 8 to 9 months. So now this what we did. This is a new age e-vehicle that Mercedes was trying to develop, and they wanted to test a gearbox in different oil. So now to the other side. So this is a tank. Inside which the gearbox is, and different lubricants with different impurities are loaded, and they try to analyze what is the impact of impurities on your gearbox over a cycle, right? So there's a predefined test cycle and all those things. But Indian team does not have the expertise for analysis. So this entire setup is inside the Mercedes currently in Bangalore. So what we have done is we have put up all these boxes. These black boxes we have put up. So it captures different parameters like viscosity, temperature, impurities. We also have a camera which will live stream, and they've also injected few specific inside the lubricants, so to see how the oil flow pattern is during operation. So now these kind of parameters we used to capture and live stream it to Germany. So the analysis should be done there, and it was like a closed loop. So they do the analysis, give the set of parameters that needs to be modified, and they redo the test. So we created the entire setup for them for doing this analysis. Industry. So completely non-specific to vibration. So now these guys basically make your metallic shelves and almaras and things like that. So this is primarily a powder coating industry. So now the issue was the green liquid that you see here. This one is nothing but an acid bath. There is 7 stages of acid bath dip the metal has to go through before it goes to powder coating. So the problem here was the acidity of this bath is supposed to be precisely measured. Unfortunately, our beautiful team sitting there used to do the calibration once in a month. So whenever we go and ask the guy in the floor whether you have calibrated, he says yes, I did today morning. So you show the records, it is written on the same value. So it remains the same. The quality keeps dropping. So when we actually went there and did the survey, we realized this fellow was doing the manipulation of books. So now they wanted a mechanism as to improve the quality. So now first examples that I took was to demonstrate how do you cut down on your unplanned downtime. So now this is to improve your quality. So for improving the quality, what we did, we put a pH sensor inside the bar and we continuously monitor every once in an hour or whatever frequency customer needs. So this will help them understand the pH level and try to calibrate it whenever needed. And then, I don't know whether this is visible, a very small box here. We have, we had made an air quality sensor for them. So this is a very interesting and unique air quality sensor. This is basically a Bosch chip. So we import the chip from them and we make the circuit around it. So now this Bosch chip is AI enabled, right? So we were one of the first people to try to get the samples from Bosch and make the circuit around it. So now, very interestingly, this is an AI enabled chip. So what does that mean? You take a filter coffee, take a cappuccino, switch on the sensor, keep it on top of it, and then you click on record. It records the signature of the filter coffee, and then it records the signature of a cappuccino, and it stores it in its table. Next time, you have a coffee, it will try to classify what kind of coffee it is. But it's not restricted to coffee, so they're not working with coffee, but rather they're working in a factory. So here you can train the sensor to basically identify intelligence. But here what we were trying to measure is more into do with AQI index. So what is AQI index? It is air quality index, which basically specifies how good, bad, ugly is the air in your surrounding. So not only India, worldwide it is stated that indoor air quality is worse compared to outdoor air quality. Imagine Delhi where the air quality is already worse, inside what might be the situation, right? So now here, the issue in this industry, it's a powder coating industry, right? And neither the owner nor any of them have any concern to the employee's health. When we went there, all the guys eyes were red. Throat infection is almost all the time because that fine dust particles entering your nasal cavity creates a lot of issues. You don't even know about it. So once we put this, it was the AQI index was off charts. We literally tested the limit of sensor itself. Right? So So now, once we showed that, a lot of exhausts were basically put in, lot of measures taken to improve the condition of, working place of the, employees there. This is a final, I think there are two more. Yeah. So this is another very interesting example. So I'm just trying to give you examples of the IoT can be used and how we can bring in a difference to our customers. So whenever we are looking for giving an IoT solution to the customers, of course security, scalability is very important. And then third is understanding the customer's needs and giving an appropriate solution. So as I initially told, you need to understand which is the right sensor to be used for this particular application. So now this is a very off-road kind of a project that we did, which is related to IoT, of course. This is in New Zealand. So now in New Zealand, most of the houses are double glazed. So that basically means that outdoor air will not come inside. So mostly in winters, this is the issue is in winters. Winters are so harsh outside. Double glazed glass windows are there. So now, how is the air circulation happening inside the house? Through only air ventilators. So now, what is the problem? So now, our customer is a air ventilation system installing and servicing them. So now, what is his problem? Either very old people or children go and modify the settings, and the air circulation stops. If the air circulation stops, it is a huge problem for the residents. So now they get calls like 12 o'clock, 1 o'clock for repairs. So now what we did, we made a completely IoT enabled system which gets connected to their home Wi-Fi to the central server which is in the office. So now whenever they get a call, sitting from their office, they can control all the settings of the device. So now this way, your servicing becomes extremely easy and you save huge amount of money going there, repairing and coming back. So this is the solution that we did. And now, mixing two projects. The previous project I basically explained AQI index, right? So this is a very now the testing is going on. So very crazy application. So what is happening in New Zealand? Government basically builds houses for old people and poor people in the given. So now what these people do is sub-rent it. So now the issue was people used to take this house and start cooking meth and marijuana. So now a lot of cases started, such kind of cases started. So now how do you identify now? So now these are government houses. So now that's where the equity sensors have put, and as and when marijuana smoke starts coming in, we are able to alert. Right? So now we have just given the same AQI index for doing that. So now if you ask me where am I getting marijuana to test it, I am not doing it. So we have given it to the So one more application here is coming back to vibration, but it is more of a transportation application. So now in this case, the primary problem was during transit, you all know how beautiful our roads are, and especially if you come to Bangalore, the roads are even bad. So now during transit, cracks are basically getting developed when you place during transit. So they wanted to understand what is the vibration expected during transit and at what location. So now we developed these small vibration sensors. This one, it's too small compared to the size of the window. So during transit, it basically captures the complete vibration and then gives you a pattern with respect to time as to where and where. You also have a GPS now, so it gives you also the exact location at which the high vibration was observed. It comes back as an input to the R&D team to either make the transport shock absorbers better, or your windmills can take that shock. So those changes they are doing. So we are only giving that. So these are the other work that we are basically doing. So primary objective of NS engineering was to fix our focus towards industrial IoT. Of course, we can explore and try to do other electronic projects as well, but we are very focused towards IoT. So now we understand the customer's needs and try to build a complete solution around. So from design, development, manufacturing, and supply of sensors or automated systems. So we do the entire thing like that. So apart from that, we were forced to start working on the software part of it, where we create dashboards. And now we are progressing towards AI agent customized reporting. So the entire gambit of solution that is needed from end to end, from capturing till realizing your solution, we try to give the solution to our customers. So I'll very quickly take you through the software. So now this is the software that we have basically developed for our customer. This is exclusively only for them. So now if you see, we are monitoring more than 23,000 machines presently. 68 different factories, 23,000 machines. If you see, quite a lot of big names are there. ITC is there, Anani is there, Reliance is there. We have also tried and implemented in outside India in Middle East also 2-3 sites. So for example, Bearing and Steel. So we have see this is Adani infrastructure. This is Reliance Arson. Reliance Arson is another beautiful example that I wanted to share. So Reliance Arson has one of the biggest conveyor belt in Asia. So now this is such a big site. It is 660 megawatt, 660 megawatt power plants. Now the beauty, what happened here is the coal which is getting extracted directly gets crushed and it gets it falls on the conveyor belt. It's like few kilometers, like maybe 10, 12 kilometers. The conveyor belt is that long and the coal directly goes into the Reliance plant. So that big conveyor belt. So now what happened here, this was close to 8-9 months back. So the interesting case here was since the coal is getting dug and directly put onto the conveyor belt, the JCB's the teeth, it broke and fell on the conveyor belt. So now it somehow went through the crusher and it fell on the belt and it got stuck there. And before people could realize, call and take an action, close to 2 kilometers of conveyor belt was torn. Right? So now imagine for 2 kilometers conveyor belt, if you want to change, it is going to take 7 to 8 days minimum. Right? So now what happened? This being such a massive power plant, if you shut down this power plant, it has an implication on the central grid. And these people have to give an explanation to central government as to why the power plant was shut down. So it has a huge implication. And they get penalized per minute per watt of loss. Right? So the loss runs into crores of rupees. So now, we were trying to discuss with them to give a solution. So again, we are doing vision-based, AI-trained system to see where the coal is falling, if there are any foreign objects. So if there are any foreign objects, it has to trip. So we are discussing with them to come up with some solutions like that. So now these are all the different sites. I'll just take one of our largest sites, which is ITC having close to 7,591 machines. So now what is our primary goal here is to measure the vibration of all these machines in real time or offline, and then try to classify them as normal, satisfactory, alert, and unacceptable. So now we classify them as different categories, and we give them observation and recommendations on the unacceptable machine. For example, if you see some machine is unacceptable, we give them actionable insights or recommendation as to how they can try and solve them. Of course, the probability of us solving it is not there. We just try to analyze the system and we give them recommendations and observations. So I'll just try to show today this. This is today's data which has an unacceptable machine. So if you go down to a specific machine, as I told, 23,000 machines. In each machine we monitor multiple parameters. I mean, multiple places on the machine. It might not be a single place. Sometimes it might be 1, 2, 4, 8, 16 places on the machine we basically monitor. In this case, let me see. So quite many motor side, roll side, gearbox, input side, intermediate stages. There's so many stages in the machine that we are monitoring. And of course this gearbox, if you see here, so it gives you the trend of the machine, it gives you the spectrums, it gives you the time series. You can even hear the I don't know if it was very audible to all of you, but you can even hear how the gearbox sound is inside. So it plays an important role to few people who will be able to assess if there is any issue. So I just try to play last week's scenario. This was a very low frequency issue that was identified last week. It was well below 2 Hz. It was around 1.2, 1.3 Hz. There was a beep sound that was basically heard. Of course, we have the complete spectrum analysis done. What was the issue? Everything was basically figured out, given to customer. They opened it and they cross-verified the issue was basically identified. So sound also you will be basically able to hear from the cloud. So now this is the basic system that we have created. So now I would like to interact with you guys more rather than it being a one-way conversation. If you guys have any questions, please do ask before I take you through more details and then we can kind of close it. Any questions?
Anyone want to ask any questions?
Yes.
My question is that you are monitoring a very large number of data.
Yes.
Some of them may be critical
Correct.
and which has to be attended immediately.
Correct.
How do you identify which is critical, which is not critical?
Ask.
When there is a very large number of data.
Very interesting question, sir. I'll just point out to you. So now, this is a trend graph, sir. So what we are doing, every time there is an input that is coming into our system, it gets plotted on the trend. And based on the type of the machine, whether it is rigid body, whether it is flexible, what is the kind of machine, whether it is a horizontal, vertical machine, based on that there is ISO standards. So I think I can show you the ISO standard also. These are the ISO standards, sir. So based on the ISO standard, if you see if it's rigid, flexible, and then what kind of drive it has and what is the wattage. So based on that, this ISO standard, overall values are already mentioned. So now what we do is whenever there are two types. One, it might be instantaneous, sudden something has happened, and from normal suddenly it has not been acceptable. Immediately we send out an alert to the customer and our engineer. So what our engineer is going to do is he is going to take the time series data, create the FFT, try to analyze, create a report and give it to the customer one. And second, so many cases where we have seen the value, overall value has never gone to unacceptable, it is a normal, but still issues have started developing. So there what we do is the sudden shift delta variance between the previous value and present value we see. We have a threshold event. If previous value and present value if it has increased, but still within the normal region, that also gives an alert. So in these two ways, we alert both customer and as well as our team to look into it. So this is automated.
Change in trend.
Change in trend. Any change in trend. Yes.
Just one connected question. So, is there any feedback system so that this information, feed into the machine and machine correct itself for the further cycles?
Presently, no, sir. So basically, what is happening? Thanks to all the competitors that are there, the point is because of false alerts, larger machines are getting tripped. So now what happens? It hits their productivity very badly. So now the customers have told, unless it is proven that you give thorough proof that there is an issue, we will not stop the machine. So that is the issue. And even in the case I was telling the Reliance power plant, the case was there is a huge, maybe around half this section, that big electromagnet is there over the conveyor belt. If any metal piece falls, it will just suck it up. And there is a trip also connected. Because of the old system, false triggers have disabled everything. And now 2 kilometers conveyor belt got cut. So because of these kind of scenarios, customers usually don't switch off unless it is proven. So,
what kind of precautions did you take against false positive?
okay, very interesting question. Of course, it is like a feedback. So if at all we are trying to give a false report to them, it basically gets verified once it is opened. So I'll just try to show you a few of the open system photos. These are all few cases where we have given an alert and customer has stopped it, opened it up, and then seen the fault. You can see the damage inside the bearing. So now I'll show you a few more examples. See this? How much of damage has happened inside. So now detecting this is not easy. It is very difficult. So but the problem is you need expertise to understand and detect such kind of issue. If you just see the time series waveform, what I showed you FFT, unless you have the expertise, you will not understand. Right, so now, fortunately for us, what has happened? Our customer has close to 500 class 2, class 3, vibration experts. So now they do the analysis, and we are taking their feedback and trying to improve our system so that it can automatically detect. So that's why I'm telling that ML is something that we're trying to work towards. So, but even now, the trigger happens that it does not go to customer unless the engineer verifies it. So this is the system in place now. Once we get more confidence in the system, the engineer will move out and it becomes automatic.
How often do faults go undetected?
Faults go undetected. More than getting undetected, it is about people not taking action. As of now, 163 machines are unacceptable. As of now, it's like today's data. So people are not taking action. Because it is a critical machine, if they switch it off, they have a productivity loss. So unless the next service cycle comes in, they can't shut off. So that is the problem. So we do trigger, we do inform, but sometimes they're not in a position to switch off. So detection happens more than needed detection happens. So that's another problem.
There will be multiple machines in an industrial environment. There might not be exact isolation from one machine to another. So how is that isolation is being done?
That's another beautiful question, sir. So basically, we have struggled with that for a very long time. Now what we are doing is we are making it a mandate for customer to give the RPM of the machine. So now whatever is the RPM of the machine, based on that, for example, 1500 by 60 will be a 1x. 1x into 10 times only we will maximum see. So 1600 will be the maximum F max we will set. More than that, we will not show only. So now the problem is most of the machine, our sampling has gone up to 20,000. So we can show frequency and up to 10,000. So now what happens, so many cases previously what used to happen, some of the machine frequency used to come here. Overall RMS will go high and customer will like the machine is unacceptable, what is happening, they open and the spectrum and see, it will be in very high frequency which is another machine, not even this machine. So now what we have done is per machine we at max we set and we cut off the high frequencies. So whatever is relevant to that only is visible. So sometimes others also peaks will come in. We can't avoid that one. But that again goes into the engineer's intelligence to understand, okay, now this does not belong to this machine. So,
So you are monitoring a lot of machines and you have kept your sensors at various industries. But I just want to ask, what kind of, because in the rotating industry there are a lot of components ranging from bearings, shafts, fans, weights, couplings, okay, and also the motor bars. So if something goes wrong and you have only place where to mount is on either the casing or on the bearing mounting. So how do you find out which problem is if there's some kind of malfunction your sensor is triggering? So will it identify this is because of this particular problem? Maybe fan blade has broken or something like that.
So that's what we're trying to see. First is our scope at this point of time is data collection at the highest possible precision and give a good accurate data for the engineers to analyze. That's where the engineer's expertise comes into picture. Whoever is analyzing, he must be able to understand, and that's where we are coming back to you to help us, improve the ML algorithms. Right? So analysis is not in our scope at this point of time. We are more into gathering information and creating a dashboard for visualization and doing analysis features. But analysis is in their scope. So we don't do the analysis at this point of time.
So I have one more question. So because your solution is basically relying upon the data. So how you are making sure your data is the true data, how you are validating your data measurement?
Validating data measurement, see, firstly our products are all, we are testing it in NABL labs. So all the hardware basically gets tested in NABL lab. With the certificate we basically push to the customer. And once the installation is done, at least basic thumb rule, few of us at least will validate. For example, if the RPM of the machine is 1500 by 60, one peak has to come. If that is also not coming, basically machine is, there's some issue. Or so many times what we have observed is mounting will not be proper. So noise pickup will be there, looseness frequencies will be there. So using that we will tell them a mounting issue, there is some mounting issue. There are few beautiful cases I can show where they don't even mount it properly. And they will keep telling you data is not coming, data is not coming. So now we would have to get on a video call with them and show me how you have done the mounting, you remove it and put it back. So now these are the day-to-day fighting that we do with the set.
One last question. So now this is all about the sensor relevant information that you are getting. So if the sensor itself is some faulty, not the machine, and the sensor is throwing some data, which is because of the malfunction of the sensor. So how to differentiate whether the data is the data issue is because of the machine fault or because of the sensor fault?
Yeah. So now that's where we have observed this kind of a pattern with MEM sensors a lot. So that is where I was telling you initially that 150 rupees sensors cannot do all the job. And for different frequencies you need to use different sensors. Right sensor has to be used for the right application. Same thing cannot work for everything. So now, as you rightly mentioned, in MEM sensor we have seen it hundreds of times. Today it will be working and suddenly it will stop working. But once it stops working, your inconsistency remains. So now, for example, few readings are coming fine, few readings are not coming fine, again few readings are coming fine. So there is clear indication the sensor is faulty. So we try to replace the sensor. So now these kind of triggers, basically this is the customer dashboard. We will have our own dashboard where we monitor the trends. So now any inconsistency in readings, then definitely it will come out. So now, of course, thankfully our customer has good legs at the site. So there are people to go to the site and visualize it. So now if we alert something, we tell the engineer, they go and check at the site if there's actually some vibration has increased, some issue has happened, and or our sensor is faulty. So we replace the sensor.
What is your mindset
Mindset when we are
how should we think, like who started a company? You started
doing this.
so the thing is how our mindset should try.
I'm sorry, I did not get your question. What should be your mindset for starting a company or
How we need to build our mindset,
for approaching a problem?
project problem.
Yeah, so very good question again. So now, so as I was emphasizing on the point that one solution does not fit all, understanding customers' needs, specifications is the primary input that you need to take before you start giving a solution. So this is something that most of them fail because they try to sell what they have. So if, you take a problem, try to fit what you have for their problem and give a solution is usual mindset. But you really need to understand, is this the right approach? Can you optimize on the cost or can you optimize on the performance? You need to understand before you basically try to arrive at a solution for a customer. So now, for example, I showed you the New Zealand project, right? It is like a residential building. So I cannot take a mesh network Bluetooth that we have and put the entire thing there. It does not even make sense. So first is understanding customers' needs and requirements, and then approach with the optimal solution should be your goal. So not fit what we have. So that would be a better approach. And especially when we are looking and few people fail at the concept of scalability. Yes, and as a prototype, you will be able to demonstrate. As a MVP or minimum viable product, you can show it to them. But when you go for production, what are the things that fails? That comes with experience. So that is something that we always need to look at, which most of them fail. So if you see online, I'm just following some guy on Instagram also. Every day he make one project and he will put it. Right, so he's also claimed that he has made the world's cheapest vibration sensor, which is hardly 200 rupees. So now, can you expect that to work? I have a few videos. Steam is hitting the sensor 24/7, and a few places, customer when we make this box, taking one reading takes 15 seconds, right? Then the customer came back saying that 15 seconds is too much, reduce it. I said, well, 15 seconds you can't wait and take a reading. So that was my question. Then they invited me to IDC. I went there. So then they took me and then you take the reading. It is, there are huge holes where the paper is basically getting dried. For drying the paper, from bottom, hot steam is going to come. Right? You go there, you can't stand there for 2 seconds. So the guy who went there, he stood there for 15 seconds. When he came out, his hand was red. Right? So now, without sitting in our lab and trying to think everything we can do is different, going to the site, changes your perspective altogether. So I'm making a point now. My team has to go to the site, experience and come back. So then, once they're doing in the lab, they realize the importance of that. Right? Any other questions? So hope you guys got some insights in today's session. So my primary objective here was to give you a thought process of trying to understand the importance. Of course, the biggest part in the entire conversation is I try to concentrate more on how mechanical applications require the advanced technologies like IoT to push the. What is the importance? So now I hope that is clear. So now, of course, for any profitable organization, productivity is at most important, and to achieve that, your unplanned downtime has to reduce. For reducing unplanned downtime, you need data. So for improving, for getting data, you need sensors. And mechanical guys are the only guys who would understand where to put the sensor, what kind of sensor has to be put, and then of course once the sensor information comes in, how do you analyze? So you go and ask the computer science guys to evaluate a FFT and tell whether it is a inner bearing fault or anything. They'll be blank. They will not even understand what is happening, right? So now the right domain knowledge is very, very important, and you guys have that domain knowledge, right? So now only thing is we just need to put the sensors in place and get the data. You guys will be able to analyze it. So when we started with the ML, we have changed close to 9 experts in AI ML. They don't understand anything. They have set of 10 algorithms. Just randomly put all 10 algorithms on the problem. Whichever is giving you better efficiency, this is your algorithm, they will tell. The domain expertise is very, very, very important. And you guys have the domain expertise to basically improve the productivity of any industries or factories. And it is extremely critical. That is what I wanted to, give the thought process. And second is, of course, the primary, concept of using the right sensor for the right application. So now these are the points that I wanted to cover. Hope that has been conveyed. So if anything else is needed, please feel free to, contact me anytime. We can definitely help you out. And
I have one question. Now that you are trying to see where the problem happens in their machine, so do you use digital twin websites that measures their whole factories on how much RPM and which power they should run to help their machine to remain safe and do production, or you consult and appoint engineers to set the basic limits of your sensors to alert them for mishaps in the machines?
Yeah, so digital twin is of course the biggest trend that is going in market at this point of time. As the name itself suggests, digital twin is trying to make a complete twin of your entire factory where you can visualize. So we are halfway through where we are able to visualize all the machines in the factory, but we have not gotten the PLCs and the process automation into the system as yet. So that we are working on. And to make it completely 100% automated, we need a lot of ML models which can do it. That we are working in progress. Presently, we have employees or engineers who basically take the data, analyze it, and then give to customers. We are in the process of automating it. So that's where we are trying to get in more engineers. So we are growing and we are trying to get more engineers to help us out, finish those modeling. So now that's where I was again linking back to the same conversation. The issue is, I can't go and talk to the computer science guy and tell him, make a ML model. He does not understand anything related to mechanical. So, and mechanical guys have to upskill themselves with certain amount of data science and, ML and AI so that, they can bring their domain expertise into this field. Right? So, getting the right, set of people to help us do this is difficult. So, that's where we are working towards. Anything else?
Sorry for interrupting, guys, but as we are running out of time. As we are running out of time, let's save our questions for the further segments. Thank you so much, sir, for sharing your insights with us and experience. On behalf of MESA and IIT Palakkad, I would sincerely like to thank you for taking the time to be here with us today. As a small token of appreciation and gratitude, I may please request respected Head of Department, Dr. Dinesh Shetty, sir, to the stage to honor to honor our Akshay sir. Thank you, sir. We are truly honored by your presence. Now I would like to kindly request Professor T. Sundar Rajan, sir, to share few inspiring words to the young mechanical engineer students.
A very interesting lecture. I don't want to really disappoint you. As the speaker mentioned, see now connecting sensors to, let us say, any kind of mechanical or whatever industry, collecting data is very important as it appears. But then if you really want to increase the profitability, the change in the trend of the data, connecting it to the fault, as I said, that has to come from the experts. So as you already mentioned, most of you are the experts in this area. There is probably an area where a lot of work is possible. I think also looking at some possibility for interaction and so on. Basically, if you find that you keep on collecting data, there is a sudden change. What is it due to? Is it due to some bearing fault? Is it due to some unexpected event, something fell down? So, one possible way would be earlier, in olden days, in all industries, they would do things mechanically. Maintenance department will be there. So those maintenance department will look at whatever faults are there. You will have some register where you will enter this fault happened on such and such day and so on, and what was done to it. All that information now has been digitized. And wherever all this kind of thing which was done by people, now we have to do it using sensors and let us say also programs which can help us in identifying the faults automatically. So there is a very large scope to really invent things or connect, let us say, data to the fault. So I'm sure that some of you may be interested in doing projects in this kind of a thing, and definitely I think that is the way things are going. Everything is getting digitized. So for a mechanical engineer to really let us do a very satisfying job, I think it is important to pick up, let us say, how the environment is changing around us. Almost even all financial aspects, everything is being very digitized. So which means your engineering knowledge has to be digitized. And I think if you don't have the kind of expertise required, probably this is the time to, let us say, do some courses on these kind of aspects. I think even in mechanical engineering, we do have quite a few courses which are talking about measuring things using sensors. I think Saji is probably going to teach a related course next semester. So look for such courses in the department, equip yourself with those kind of courses to be prepared for the future. See, I studied about 56 years ago. That technology is over. The technology that is there for you, you necessarily have to understand digital engineering. Let me put it that way. So each and everything, measurement is getting digitized, the control, all aspects, right? Even finding faults and then correcting them. So the closer you are to understanding that kind of, let's say, digital economy, it's better for you. We do have opportunities to pick up these new technologies, new courses are being offered. So prepare yourself for this kind of, let us say, future. Okay, this is what I want to say, but in our department itself, we are proposing new courses. So please take advantage of those. Thank you.
Thank you so much, sir, for your inspiring words. Now it's time for the one of the most awaited segment of the day, the panel discussions. This is where ideas meet experience and questions meet wisdom. We truly are honored to have with us a panel of distinguished professors. I would like to invite Dr. Keshavan sir from manufacturing field, and Dr. Sagi Ratnavraj sir from design field, and Dr. Krishna Sheshadri sir from thermal field, and our guest speaker Dr. Akshay sir from industries, who have the theme for today's panel is to bridge the gap between classroom learning and the real world engineering. Our goal is to hear from our panel members about their experiences, opinions, and advice for us, the next generation of engineers. Now, let's start our discussion. I would like to begin with few questions for our panel. What exactly is Industry 4.0? Why is it important for mechanical engineers?
So before taking this question, thank the speaker for his insightful talk on the fault diagnosis field, which is most important, and we don't find expertise in this domain in this so which is much needed with respect to industry aspects. So thank you, sir, for your wonderful talk. And taking this question, Industry 4.0, and it is I heard this word almost like 9 years before, Industry 4.0. So to understand Industry 4.0, then we know what is Industry 3.4, 3.0, 2.0, 1.0. Are there any other industry revolutions before? So Industry 4.0 essentially is the industry revolutionary outcome. And if you look at initially industries or at the time there were no concept of employers, productivity, and whatever the modern aspect of industry engineering were not there. So they were looking into only the aspect of manufacturing things without knowing what is manufacturing. They make a product and without understanding the productivity and safety. So there was the original era of as the time comes, the 18th century, 19th century, 20th century, and present era, we understand all these systems, and currently it is up to the mark wherein we can actually get all systems which is integrated with the software and hardware with more often sensors, automations, robotics, and all those things. At the same time, we are keeping that the productivity is increased with increased safety, right? So that is the one way we can actually put into Industry 4.0. This integrated system with the mechanical, cyber physical, automation, sensors, and all these various aspects, aiming to increase the productivity and at the same time reduce the risk to the life.
Thank you for the wonderful insight, sir. What I basically feel is actually Industry 4.0 also the talk of yesterday. Now people are already talking about Industry 5.0. So we must upgrade ourselves to the future rather than catching up with the past. Right. So now I mean you guys just Google. There are something called dark factories. Have you heard of dark factories? Yeah. So basically dark factories are where nobody works. So everything is 100% automated. So now a lot of factories in China have drifted towards dark factories. Basically that means that there is no light, there is nothing, there's just a machine inside in their room and every production is happening inside it. And there's a single person to manage the entire factory. So now that is where future is looking at. And where are we progressing towards is customization. Now you see Reebok or Adidas or any kind of common goods that you are getting now is all standardized. Like you have a model number, right? So if you take a specific sneakers or Reebok shoes, it is the same model with the different sizes that you get. So now where we are moving towards, where Industry 4 or 5.0 is looking at is customization. I want red shoes with yellow, Nike symbol on it or whatever fancy ideas you have. They do manufacturing a single unit for you. And that is not done physically by a person. Everything gets automated. Right? So now that is where people are basically moving towards. And how can mechanical students with mechanical background contribute to this is with tons of expertise that are needed for automating this entire process. It's not easy. Everything cannot be done through software or electronics. A ton of work is needed from the mechanical students as well. Right? So now as basically mentioned, as sir basically mentioned, the kind of systems that were placed before, the accuracy and precision people were getting before is still very good. So now a lot of things can be done the mechanical way as compared to the completely code oriented or electronics oriented. So now the expertise and the ideas are very much needed. How do you customize and automate things in these kind of dark factories? And also, have you guys heard of MESA? Boston Dynamics, they have created a dog, it's called Big Dog. So now the Big Dog is basically embedded with sensors. You don't need people to go to the factories. I was explaining the other time that when it's so hard, people can't go. The dog basically goes, takes all the readings and comes back. So just Google it, it's just amazing. I hope you've heard of Boston Dynamics. No? If not, check the videos. For a certain time, Google owned it, and for a certain time, Hyundai owned it, and I don't know now who is owning, or I don't know who is owning it now. They have amazing systems. They have Cheetah, they have Peacock, they have a lot of different robots, and even I think Elon Musk is also planning to launch this robot now. And apparently, the story says that these robots are used in the factories for Tesla manufacturing also. So that is where world is moving towards. So definitely we need to get up to meet the future needs.
I think Dr. Keshwan and the speaker have already talked about how this is relevant to the manufacturing industry. I just want to give a kind of perspective that is perhaps a lot more generic. So when we talk about Industry 4.0, it is essentially to leverage the latest techniques and let's say robotics, sensor technology in order to increase productivity, as has already been mentioned. But this need not be restricted just to the manufacturing industry, any kind of process industry will benefit from the optimization of processes. So if you, I mean, to give you an example that's perhaps a little more easy to understand, if you have watched these old style movies like Ben-Hur perhaps. So in the movie they show who were slaves at that point of time rowing these huge ships. When they were moved using, I mean, these are ships with kind of windows on the under the deck, from where long poles would be pushed through, and then they will row this thing. And these are not sail ships. And then you obviously watched Titanic. I'm sure you have watched Titanic. In that, when the guy in the crow's nest suddenly spots the iceberg, he he hollers to the captain, and then they immediately send a signal. They just push a lever, right? And then it is the signal again is sent to the below the deck, where people start to pump in more and more coal into these huge steam engines, which eventually propel the ship forward. And now, of course, if you have had a chance to look at the kind of engines that we have in these large ships, these are all either run using gas turbines or big, large diesel engines. To give you a scale of the engines, these have bores of a few meters diameter and a stroke of also easily tens of meters. So they're really huge. So if you look at these, the way this simple technology or what has been done by human beings for a very long time. People have been sailing for a very long time, and how even the propulsion has changed over time, and how it has become a lot more efficient. Now, marine engineers need not even go to what is called as the engine room to monitor the operation of the engine. They can sit along with the captain perhaps, and they can look at what is the in-cylinder pressure. They can look at what is the vibration levels, and based on the latest tools, they will also be able to predict if there is some kind of failure that is going to occur based on the vibration levels, or suddenly the pressure relief valve will go off because the pressure is too high inside the cylinder and so on. So this is not just something that is relevant to the production line, but something that also has applications in almost all areas. Okay, so if you are trying to optimize a process, you can make use of this data that has been collected over a very long period of time, and with the new sensors coming up, the amount of data that is being collected is even more of late. And as to the relevance of why mechanical engineers need to learn this is, as he mentioned, it's not just sufficient anymore that you have hundreds of workers working on the shop floor making a very simple product, because we are moving towards automation, and beyond the ethical question of whether it is good to replace men with machines, unless you keep yourself abreast of the latest technology, you will be left in the lurch. And so for that reason, definitely as mechanical engineers, you must familiarize yourself with all these concepts and also build your capabilities.
So I'll share my views on Industry 4.0. So my colleagues already have given how it is being linked with the manufacturing and government side, and as well as Industry 5.0 as well from the individual speaker. So here in the design viewpoint, for example, nowadays, same product has been manufactured by different organizations. So the biggest challenge is the speed to market. So every time the design has to be changed according to the customer needs. So if you want to do the designs, so the latest design, so it is very difficult to come up with every time a new design that suits the customer requirement. So can we leverage the information that the design information that the organizations have been built from the decades of their from their organization. So what we can do is we can take the Industry 4.0 solutions, which can leverage the information of the past information and past design information. They can come up with generative models, so which fits the customer requirements, and also they will identify not only the design but they can also come up with whether this design can be manufactured or not. So this kind of design problems can also address using Industry 4.0. So it is not that we, as a mechanical engineering, we should look forward how the existing information can be enhanced and address the current requirements, the industry requirements, or the society requirements. So from the design stage itself. So this is what I feel from the design aspect. We should think. That's where I always encourage the students to understand the simulations, how to build the physical models, so that you can understand the behavior of the physical models before it is being manufactured, and you can subject these physical models to the real-time, operating conditions and see whether these models are working as per the customer needs. So that's how we need to took up this because industry requirements are evolving, so we should get ready. So I feel like Industry 4.0 is have a lot of given that situation, so we have a lot of opportunity to learn and take this as a responsibility from our side to understand, because as the faculty members are saying that we will not only need the technology, but also without the domain knowledge, technology will not help. So we have the right opportunity. So mechanical engineers all must be required, and if you have the Industry 4.0 technology, so then that will be the better that adds to this height. So I think that's what all about Industry 4.0 from the design point.
Thank you so much, sir. Before going to the next question, I would like to request just to answer the question briefly, sir, like shortly, because we have time constraints and many more questions. Thank you, sir. The next question is what new technologies are most relevant to mechanical engineers?
I don't have a direct answer to this. Technology I don't have straight answer to this. What is the most relevant technology that are available? But if you look at there are several technologies. If you Google it, you show 10, 15 technologies start from AI, ML, data science, right? Augmented technology, vision-based. There are several technologies. But what is most important is what is your interest. In addition to the mechanical engineering core domain that you gain from the institute, right? So some of you may have actually really good in software. Instance, you will be good in actually writing codes, right? And see how you can develop that with respect to your core, so-called mechanical engineering for all of us, and see how you can apply that to the field or the business. So that's how I actually look into this to answer very quick. So there are technologies, and just to make sure what technology suits your interest, then you equip yourself during the time at the institute by doing a small projects. Let's say currently we have OELP. You attempt actually 2-3 OELP with respect to those technologies, and equip yourself and before you get into the industry.
Adding to what Sir basically said from an industry perspective, I classify very clearly into few segments. If you are interested in design, ensure you are very good with CAD, AutoCAD, and then Blender and 3D printing. And of course, there are a lot of tons of free softwares like FreeCAD or anything where you can design and then 3D print. Be very comfortable with that. So, from an industry perspective, we really lost a lot of money because of not having the skill set and 3D printer, and which we realized it off late, and we have got it in house now. So from a design perspective, please look at VCAD or AutoCAD or any CAD design softwares and 3D printing. From a analytical side, if you are more inclined towards analysis, equip yourself with MATLAB, Python, and such kind of languages. Then, of course, certain amount of mathematics to back it up. So that would be from an analytical perspective. That's
Yeah, so this is actually kind of trying to add to what both of them have said. In fact, if you take the OELP itself as a specific example, we have been doing it for close to 4 years now, and most of the projects where you are building something, you will have to initially do the drawings, draft the components that you are going to manufacture, and then it would probably be using a 3D printer that's available in the innovation lab, and so that part is also there. The rapid prototyping is also something that you familiarize yourself with. In addition to that, it's, I think, also important to be familiar with at least very basic level of structural analysis, which is critical for many components, especially if you are going to use it for a specific kind of application. Okay, so, and you know what kind of loading it can be subjected to, whether it would be kind of an impact load or it is a cyclic loading. So all of these very simple structural analysis you should be able to do. And similarly, if it is a kind of a flow system that you are trying to build, it's also important to learn some kind of fluid dynamics simulation framework. All of this will help you in analyzing it in a very fundamental level, and also for you to know what to expect when you actually incorporate it in practice. Okay, so that, I think, is these are two. I mean, these are skills that you can develop.
So apart from my fellow members information, so I just want to add one point. You can also get hands-on on the computer-aided engineering softwares, be it ANSYS, Abacus, console, so that the industries, the first thing that you enter into any industry, they will ask you to work on this kind of tools and their respective problem statements. So next thing is if you have the machine learning and artificial intelligence knowledge, so how you can get the information coming from a huge data, so how you can refine the huge data and using the AML and get the useful information to the organization. So that is what also a lot of companies are looking for, because of this digital revolution. So data is coming in the huge form in wide variety of different natures. So if you have the skill of refining the data and giving the valuable insights to the organizations, also is most required skill set for the many of the industries. So apart from the other members, I think these skills also you should have. Thank you.
Yeah, just to add one thing here. So if we talk about the technology, you should think of a future of technology. Say, example, now everybody is talking 3D printing and manufacturing, right? If you take some 15 years before or 20 years before, so it was not actually that popular. Okay, so now you see almost good number of theses coming out of from PhDs from 3D printing. It is almost like we don't know actually under this what slope it is, whether it is reached peak or saturated. But if you have interest, you think about the future of 3D printing or any technology which is advancing now. You think about the future of the technology and you start actually equip yourself to get into.
Thank you so much, sir. As sir mentioned now about 3D printing, like how are 3D printing and additive manufacturing changing the mechanical design?
It completely changes is both from a design and manufacturing aspect. So if you look into the conventional way of design, so we call it as forward engineering, right? So mostly what we do with the help of CAD, it is a kind of forward engineering, and with the forward engineering we can actually make even very most or complex component design aspects. So with the help of 3D printing, there is possibility of actually making a reverse engineering. Even say for example, you look into the structure like bones, right? If you look at the cross section of bones, you can see how critical it is, right? Can you think of designing such structure by conventional? Even if you design, there is no manufacturing method to make such a complex component. Even if you design, what manufacturing method would you actually prefer to make such a component, right? But when you think about 3D printing, it gives the solution, right? So you can actually do reverse engineering. That is another approach of design. Reverse engineering, just get the point clouds and you can generate the data and make its design, right? This reverse engineering. Once it is ready, just feed that into machine. Machine takes care of this. That I'm talking about the 3D printing, right? It can be polymer, it can be metal, or it can be any sort of machines. It takes care of designing any complex structure. So there, the limit is only our imagination, right? You can actually think of printing any component to any complexity level beyond your imagination, right? So 3D printing actually offers this flexibility or freedom for both the design and manufacturing with this.
So, from an industry perspective, we have seen time to market has reduced. So, for any company, for us, the biggest thing is, how fast can I productionize it? When can I start getting money out of it? Right. So now, initially when we were doing it, it used to take a lot of time. So how would you prototype? Before we used to either go for rubber molds. So at least you have to do the molding, create a rubber mold, and even if you do a rubber mold, how many units can you get out of a rubber mold is hardly 20-25 at the most, and then the mold is done. So now, if you want to do any change, again gone. We are back to square one. So 3D printing has helped us a lot. So in a day, in 2-3 days, I can get 4-5 different variants of the prototypes. So now that really helps us a lot. And cuts down the time to market so that we can go ahead. So now that has definitely helped us. There are multiple ways in which you can prototype, but most convenient, easiest way is of course the 3D printing.
I also feel that the maximum advantage of 3D printing is in the prototyping area, because you can try out your design as and when it evolves by prototyping it and maybe conducting few preliminary tests on it, and by sort of implementing it in the actual production or in the field. So that I think is one of the major game changers for the industry in terms of reducing the time for your trials.
So one funny incident I think to sir is that nowadays it has become so easy, user friendly, is that when my team wants washer, it's not going to the shop to print the washers. So it also, because it's isolated, right? So plastic will be isolated washers. So instead of even going there, people just print. So it works out way cheaper than going to the shop and getting it. So that's how fast things are. And then also adding to service, your creativity is the limit. So how much ever creative you can get, that much things you can print. So in Bamboo Labs, if you see their open models, there were few guns. So now I have convinced my son not to buy toys. So let him print whatever toy he wants. So he goes to the Bamboo Labs, this one, they have their website. He searches even the gun, nut, bolt, joint, everything is printed like one shot. So that's how simple things have become.
I echo with my panel members. So I don't have any additional views to this particular point. You can go ahead.
Thank you, sir. Moving on to the next question. What are the biggest challenges for mechanical engineers in adapting Industry 4.0?
So challenges, maybe I can actually refer speakers' presentations. Okay. So there are 163 systems which are shown red, which alerted, but still we have not actually taken action on it, right? So this is a conventional approach, right? So conventionally, actually, we adopted one system and we tend to follow the same system, okay? And I'm seeing it like the purpose of actually putting a sensor is lost, right? So the purpose is it has to actually gives us the information and we have to work on it and rectify it and give some feedback so that the system efficiency is increased or time is reduced or whatever the benefit we get. So here for the biggest limitation is to get into the system and quickly actually see what system is expecting and understand. Sometimes we may not have that domain expertise, right? So that's when actually we need that so-called liquid learning. Okay, so you heard about this liquid learning, which completely may not be your relevance or your background or your field, right? It may be completely different, which you would have not even heard about it or not even studied. Okay, so during your undergraduate or even postgraduate, right? So this is the most important skill required for students. That is like when you get into the industry, you don't know what kind of challenges will be posted in front of you, right? This liquid learning is quickly you learn those new topics, which is completely new, and try to deliver some useful actions against the challenges posted to you, right? So I'll keep it this simple way.
So I feel there is no limitation. So it's only about your mindset. So when somebody else is able to do it, I'm sure you guys are way more capable compared to others to get it done. So simple example, I had one student around 8-9 years ago. He's from mechanical, but the amount of electronics and computer science he knew, I used to get scared. So whenever he gives me a call, sir, I have a question, I want to talk to you, I used to ask him, send me the question first. So let me prepare myself before you come. So don't limit yourself, it's just your mindset. So if you can think you can do it, definitely you can do it.
Any other comment? Sometimes the financial issues are so staggering. The whole world has changed over 10 years. But still, United States has everything in FPS. Because if they have to change all the manufacturing lines and so on. So which means any new technology, there is a problem that you will have to completely change the entire production, and for that to start yielding profit, it takes time. So you would rather continue with what is already there. So CMK system came almost 50-60 years ago, but still they are following FPS only. So sometimes there is a resistance to change because the cost involved in change is too high. So that is one problem too. So very, very often the economics of it seems too staggering and then they don't want to do it.
My opinion, more than a limitation or a challenge, I feel that you should be ready to, you should develop troubleshooting skills. You can get data from the sensor and of course there can be a lot of these AML models which will tell you what the fault is, why it is happening based on prior history. But at the same time, if you want to solve it or if you want to remove the issue, sometimes putting a duct tape might not fix it. Right? So you should understand what is causing an issue or how to really make sense of the available information. And for that, of course, you need to know all of the fundamental principles thoroughly. So if you are limited by the understanding of these fundamental principles, then that will cost you dearly as far as these industrial automation, Industry 4.0 is concerned. So I think that should not limit you, and you should be you should possess those very basic skills to begin with.
I don't think so. There are challenges. Obviously, there are a lot of opportunities as well to address the challenges. So think in the opportunities perspective. So as we said that all the technologies what we discussed, I think that will help you out to address the challenges in whatever the domain that you are working for. So whether it may be a research problem, whether it is a product development problem, or it may be an organization problem. So think for the right tool. So that because the conventional way of approaching has been now not given much importance. So it is better to use the current technologies to address your problem. So because everyone wants the solution very fast. So there is no one to wait for the solution. By the time you give the solution, somebody is ready with the solution. So it is a time that the students should think of not only getting the understanding the basic mechanical stuff, but also how we can leverage the technologies around us to address these challenges and convert them into opportunities. That's what I want to comment on.
Thank you, sir. Next, we would like to know how Industry 4.0 promotes sustainability.
Okay, question starts from me. Okay. Sustainability.
Sure. I think sustainability is a broad term again, which talks about how you can effectively utilize resources, and obviously Industry 4.0 by optimizing various processes for the manufacturing industry, and for that matter any industry, helps in effective utilization of all the available resources. So I think that is the main driver of sustainability itself. This is not just about, again, physical resources. It's also about human resources. You do not have to employ, let's say, 20 people where you can do the work effectively by having just, let's say, 5. Okay, so that is also in some sense a sustainable practice, because in the long term, having optimized processes will help in sort of keeping these resources available for the future generations also, which is essentially the core of sustainability.
Maybe I can actually give one example. So we are seeing windmill, right? So around maybe in Nagalia campus, or you would have seen windmill. Okay. Take example of, let's say, these all whatever close by windmills, they are about I think 1 or 1.2 megawatt. Right? Consider if 3 megawatt, 5 megawatt, or more than 5 megawatt windmills. If any fault, right? So the complete system has to be brought down to the station. Okay, just for bringing that system down, the cost involved is almost like 15, 20, 25 lakhs, depending upon the megawatt, right? So the cost is not to actually diagnose and attend the fault. This is just to bring that system from top tower to ground, right? So that much cost is involved. If we incorporate, let's say, Industry 4.0 or digital twin, so which is like twinning of the actual system, okay? If we monitor and if we put the right sensors in the right locations or the critical component or critical locations, and if we monitor those results, if we monitor those data and address those issues, if it is raised during the right time, we can save, right? So this is one way actually we can look into the sustainability. Okay, so through this, by adopting the new technology, by adopting the Industry 4.0, by adopting the sensors and right softwares, we can actually reduce this gap. Okay? This is how now I look into this here.
So there was one quote that I told previously: without data, a person is blind. So, Industry 4.0 basically gives you all the information that is needed for you to take corrective action. So now, what is sustenance to ensure that the industry moves ahead? There is still production going on, still remaining profitable. So for all these three things to happen, you need data. So Industry 4.0 basic fundamental is to provide sufficient data for you to take action on. So now, to adding to another point that Sir basically said, so now not only identifying the issue, now we are also looking at how do you look, what is the remaining useful life? Because certain machines might have come into faulty, but there is circumstance that stops you from switching off. So now in this scenario, how long can I still run? So do we have the spare part to get and do the replacement now? So how will you get all that information to Industry 4.0 sensors? So now that helps in your sustenance. So one of the key factor contribution in Industry 4.0 is to go towards the sustenance of our industry.
So I agree with all the points shared by the panel members. So any technology that you are using that helps the wastage of the natural resources, that's where the whatever the sustainable goals is also all about. So I feel like the Industry 4.0, whatever the technologies people are trying to use the technologies to address to reduce the wastage and natural resources in the process of or maybe product development or any kind of equipment maintenance, like what actually is saying right now, the remaining useful life. So I feel like we need to think our engineering design. Like there's a circularity in the design is also coming up. It's not that we are not once the product has been fed, for example, a bearing has been fed. So can we retrofit the bearing and reuse it? So now it's not about the manufacturing the new product. It is about we need to think that how we can retrofit the component that has been used until its life to another component again make it run. So that's how we need to think forward with this particular point regarding sustainability, especially in the design.
Dr. Saji added a comment which is very close to what I wanted to say. See, now, knowledge is money. Because if you have a good idea about what the machine is doing, that itself can improve the sustainability. See, many mechanical engineers deal with machines, and there are a lot of machines used by people, the society. Cars, for example, the driver does not know what is happening with the car. I really think that if you put some sensors, which will tell them, for example, what is the temperature of water, vibration, some idea about if there is a deviation from the track, or even mileage, or something which is of interest to the driver. If you know that last month I was getting, let's say 18 kilometers per hour, now I'm getting only 16. So something has changed. If this knowledge is given to the consumer, probably he will improve the sustainability. That takes some action. Alright, so I think we should put sensors and give some kind of feedback to the consumer. A lot of people are using machines, all kinds of machines. So some simple data can be given back to the user, even as a deviation. Compared to last month, what has happened now. I think that will really help in improving the operability of the machine. It also will improve the sustainability.
Please join us.
So, like as Sir talked about data, like what role does data play in modern mechanical systems?
So data is trying to improve the machine performance. So with this data goes back to the R&D team to see how they can improve. So maybe motor, turbine, fans, compressors, whatever it is. So how is the design performing at at the site and how they can improve. So that is taken up. And very recently, I had a discussion with Siemens team also. They are coming up with a different concept. Usually, Siemens motors are basically sold, but now they are not selling the motor, but they are selling usage of motor per hour. So now the concept itself is completely different. So basically, what does that mean? That when you buy a motor, you are not paying anything upfront to the Siemens. You are just paying for the hours you are using. So what is happening? The entire concept has changed, and now Siemens is looking at revenue from the motor throughout its life. So not a one thing. So now the entire concept is changing. So of course, data is helping them. So it's like basically giving data and also paying them money to optimize things, right? So now primarily data is helping you to optimize all your activities.
I just want to say a single line in fact on this. Data is what you make of it. So for many people it might be just data which makes no sense. But if you make sense of it and you use it to improve the process, then it's obviously useful data. And so what you make of it is what data is going to do for you. That's all.
Yeah, so the data, yeah, so one of course increase the performance, and other thing is by using this data it help to improve the safety aspect. So for example, take like sir mentioned vehicle 4-wheeler. So there are so many sensors. So example, take tire pressure. They have sensor. Okay. And the integration of sensor with the tire and how the data is actually getting transferred, and you get that information is in your mobile. So for example, if you don't actually look at the tire pressure for the last 2 weeks, right? So the data actually gives an information that you look at the tire pressure, right? It is less than 30 psi or it is less than 15. So definitely you will end up with danger if you drive with that, right? These all some of the usefulness of data. So I'm just giving example only with this the vehicle, but you can apply this with various mechanical machines. Okay, so we can look at from safety aspects as well.
So in one line, I will say about this data. So I'd say one simple example. So data is like a crude oil, and coming from maybe Russia or maybe Southeast Asia countries, is a mechanical skill set, like how we are converting the crude oil into the relevant petroleum products. So data is like a fuel. Your skill set should be like a refinery, so that we can make something useful information, a useful product, or a useful components, development, whatever it is. So it is all about like what Krishna said that. So it's all about how you use it and what you get out of it. So that's what it's all about. So it's not about the equations no more. It's all about data now. So please, I request everyone to deal with more data so that you understand the importance of handling.
Thank you, sir. Like, what career opportunities are emerging for mechanical engineers in Industry 4.0?
A lot, actually. I mean, what we basically discussed from the design phase till implementation phase, it's required. So what I emphasized in the, talk also was that whether the right domain knowledge, as also other panelists basically mentioned, whether the right domain knowledge data is useless. So we might, capture terabytes and terabytes of data, but without the right domain knowledge, there's no use to it. So definitely, mechanical guys are very much needed from the design phase to analysis phase, till giving the reports to the customer, till everything.
Yes, I agree. So, without this domain, we cannot actually think of any new role or jobs in industry. So we cannot stay on conventional way of showcasing ourselves as a mechanical engineer, right? Of course, we all should be good in our core mechanical engineering, our first principle thinking, and all those things. We should be good, but that is not sufficient, right? So that will not help us to actually accelerate our growth, our career faster. Of course, we need to actually get into this industry 4.0 or IoT and other related engineering fields. So because if you take any engineering or industries, so they look for this expertise, right? So it's the right time you equip with this expertise.
I think more than what kind of jobs are there in Industry 4.0 or on those lines, I think it is more to do with the fact that the jobs are the same. You would still be a process engineer, you could be a shop floor manager, whatever. But the skills that you require now are slightly different from what were expected of you earlier. You might just have had to, I'm not trying to say that it was not a big thing in the past, but now you need to know a lot more, you need to know more technologies, you need to know how to analyze data, how to maybe provide requirements for these sensors. I mean, so you are most familiar with the shop floor perhaps, and you will ask a service provider about what kind of sensors you need to install. You will have to give the requirements to them. They will install it, and then you will be the one who's perhaps going to do the continuous monitoring of it, or in some other cases they might do the monitoring and the data analysis also for you. But I think the requirement now has changed for the same jobs that you require more, or you need to know more. What do you say? You need to possess more skills. Okay, so if you move along those directions, all of those jobs are still available for you.
So I will give good news to you. So that what I want to say here is, so all we are saying that you need a skills, right? So you want to get some kind of a technology understanding, right? So what we are doing is actually is kind enough. So he said that we are doing the internships. So if you want to really delve into this kind of industry 4.0 sensors, so I'm just taking this question as an opportunity to announce that ENMAS is ready to provide some internships for the IIT Palakkad mechanical students. So if you are really interested, so you can understand what exactly it's all about. So thanks Akshay for coming forward and understanding and giving your questions.
So now we are moving on to our last question. Now I would like to hear in one line, how do you describe future mechanical engineers?
Robots. Not exactly. So I'll take this question first. So as we are saying from the beginning, so we don't need to change much, but we need to change our mindset as per the requirements of the industry. It's all about, as I said, it's all about the speed at which you are solving the problem, not about how much thinking or thought process that you want to do. Because it's all about the speed to the market nowadays, as per the industry norms. But as per the research norms, we are exactly opposite. So we have to think a lot. We need to make sure everything is right. They will be ready to release it to the research community or to the industry community. So that's the reason. What I want to say here is, IIT Palakkad is giving good opportunity. So we have two parallel communities. One is the research community by the faculty members, and also IPTF is there, which is the product development community. So we have right opportunities to cater to the industry requirements. Whether you want to go to the research, whether you want to go to the product developments, it's up to you. But the platforms are available. So it's all about your mindset, whatever your future goals. So that's all about. You should have a good clarity. So then you are ready for the industry requirements with all the skill sets what we are just talking about from last one hour.
The question is, can you repeat the question? Question is, the question is, how do you see them future mechanical engineers? Okay. So, see, we have to actually come out of a conventional way, as already pointed. We should think from system level. Okay. We cannot, say ourselves as mentioned, core mechanical, or I have not studied this, so I don't know. So, example, so we ask sometimes, students, right? So how a simple, mobile phone screen is manufactured, right? They say, sir, we are not studied, right? So if you have actually interest, then we should know all the interest with respect to manufacturing. We should know all the aspects. So how manufacturing from, let's say, nano level to macro level is manufactured, right? And how that is actually put into the system. Okay, how the system works, right? We cannot actually isolate ourselves saying that this is my domain, so I'll work only on these things. I know only this much, right? And other very important thing is we are in the era of AI. Okay, all the informations are available, all the answers are available, right? Just with search, you can get the information or the answer. But what is most important is putting the right question, right? So being a mechanical engineer, you put the right question, right? To get the answer. So answers are available, right? But what is not available is critical thinking and critical questioning is what is actually lagging and which we need to actually improve, right? Ask the questions, right? Answers are there.
I think we are possibly moving towards a scenario where there are no more mechanical engineers or civil engineers or let's say computer science engineers. I think mechanical engineers will just be engineers in the future. That's because the lines that distinguish these branches, at the end of the day, these are just various programs that are offered by different IITs, NITs, and other private engineering colleges. So I don't think that's the point. It is about what you learn. So because everyone is learning everything, everyone becomes just an engineer and not a specific kind of engineer. But more than that, it is important to earn the title of an engineer by being, thinking at the system level, as Dr. Keshavan was mentioning. You need to approach any problem from a holistic perspective, and also address it to address the problem. You need to possess a wide variety of knowledge now, and so that probably makes you an engineer. And if even a little less of a mechanical engineer, it is all right. I don't really see that as a problem. So always keep in mind that you need to find solutions to problems and not find the problem for which you already have a solution, right? So that is certain. You already heard this before, but this is very important. There are various problems which require solutions, and so hunt for those problems and solve them. That is what you should move towards as engineers.
So what I would say in single line is, it's not only about future, past also mechanical team has run the factory, future also mechanical team is going to run the factory. They are the backbone of any industry and factory. Only the thing is the way the tools have changed, but mechanical team is always the backbone of any new factory industry.
Now, I would like to thank every of our esteemed panel members for insightful and valuable discussion.
So before that, you have any questions to ask? Okay.
Right. Now I would like to invite our respected head of the department, Dr. Dinesh Shetty sir, to please come forward and present a small gesture of thanks to our honored panelists for gracing us with their time and presence. Huh? Dr. Sagir Prasad sir. Dr. Krishna Sheshagiri sir. Dr. Keshavan sir. Mr. B.R. Akshay sir. So now I would like to request our respected professors to share some few words to the students. Last words. Now we'll move on to short open mic session, like where our panelists who are here, like with their thoughts and experience and or quick like advice, like to share with our freshers and all our audience, like. Mic ready. Keep mic ready. Okay. Like sir, were you a front bencher or a proud backbencher during the college days, sir? During your college days? Faculty members.
See, I can share what happened to me. I did my IIT Madras in the 70s. It was a 5-year program. At the end of 5 years, I felt that I didn't learn much. We had done lots of courses, and some of them very, very practical, almost, days and days of workshop practice. But then at the end, I felt probably I didn't know much. But then when I went for higher studies, I realized that most of it has gone in. So just that it had not formed a progressive kind of knowledge. It takes some time. What we have learned in college, when we start practicing in the industry, slowly, the aspects will converge. You will start seeing the whole picture rather than see about the story, of an elephant, one person sits like the trunk, other person sits like a leg, etc. But then after you finish your studies and go to the industry or go for higher studies, a lot of this knowledge will coalesce into a single thing, and your engineering, I would say, mostly is common sense. Common sense with, of course, some also, let us say, knowledge which is, let's say, structured knowledge. So if you have some idea about it, reasonable, that's good enough. So don't feel that you didn't learn much during BTech or anything. When you start practicing it, either as an engineer in the industry or for your higher studies, you will find that most of the knowledge is already there. Maybe you have to brush it up a little bit. You people are very fortunate that a lot of things are available in the internet. So through Google or anything else, you can search. But the only thing is, you have to be, if you have good motivation and are sincere about learning something, you can learn anything. Anybody can learn anything. I don't believe that only certain people can learn certain. That's not true. If you want to learn electronics and system, you can do. There is no problem. And as some of the faculty members mentioned, at the end of it, don't confine yourself to just only mechanical engineering. You have to know a little bit of electronics, you have to know a little bit of software, and so that will be necessary, because in life, problems are not very specific mechanical problem or electrical problem very specific. As an engineer, you will be expected to do anything, and you will have to learn. If few other things as well. But if you are sincere about it and work hard, you can do very well.
Thank you, sir. With your experience, I think most of them here, it will be very helpful to them, most of them sitting here. So the next question is, how did you feel when, on the first day of your teaching career, excited or panicked?
Okay. So maybe I'll just answer your previous question as well.
Okay, sir.
The previous question was whether I used to sit at the back or front, right? I used to sit at front or middle by force because by the time we get into the class, back seats are occupied first. Right. So coming to your second question, whether first day of experience, right? I was very much nervous, right? And I felt at one point of time that 2-3 hours of preparation is not sufficient to deliver 50 minutes. So that was my. So though actually I joined IIT almost 7 years of industry experience of my PhD. So day one I find it bit nervous, and I enjoyed those classes because fortunately first batch of student they used to be extremely good in terms of class behavior and hospitals. They used to interact, they stop the class, they interact. I like that, and slowly at the end of the semester, I got to experience where I can handle the class. Right?
If they want to answer, sir. Same question.
Okay. See, the problem with PhD is you do very specialized kind of work, the highest level of modeling, highest level of experimental work, and so on. After finishing it, when you come as a faculty, let's say if you teach the first year student of beta, you have to come down. Alright? For many faculty, the problem will be that you have learned at the highest level and you try to teach at that level. So first time of teaching is invariably a failure. Because you cannot come down to the first year student level, and then you won't even know what are the doubts the student is having and so on. So it does take some time for you to slowly come down and understand that whatever you taught has not gone in. So maybe after teaching a course for 2 times, 3 times, then you will adjust the level. Till then there is a problem.
Thank you, sir. I was about to ask another question. Where is it? 1 minute, sir. When you first went to the blackboard to write an equation, did you feel nervous when you were in your student life?
Yeah, I think the answer is already given.
Yes, sir.
Writing the equation itself. It's about explaining to the students. So, you could write the numbers of the equation and explain each and every term at various levels. Okay, you can say this is the unstable term, this is the non-linear term, and so on, the convective term. So the problem is how you pitch it to the audience that you have. If it is a research seminar, then it is at a different level, and if it is for a UG class or for that matter even PG class, it is at a totally different level. I think, I was not nervous to write down the equation itself, but I probably did not even realize at that point that what I was conveying did not reach the audience. Probably happens even now, for the matter. But the thing is, we only understand it a little later. That the students are not really following what you are saying. It's a learning process for us also, and I think it takes a good 5 or 6 years before you get the hangs of it in some sense. Probably even longer. So,
Sir, the question was
okay for the students, but
the question was during your student life, sir. During your student on blackboard. Thankfully, no one said they are not callers.
very rarely we used to be asked by our teachers to write something on the board. But I don't recall having written anything on the board or being asked to.
One additional thing is in teaching, they say knowing things different than teaching. So I know, but I don't know to teach. No? So this comes only with experience. So initially we were nervous. Of course, I was nervous and they were glad. I know it, but I don't know to teach, to convey this to the students' levels and their understanding. Right? So there is not only students also participate in the discussion. So I encourage students to participate in class asking questions. Right? So that will promote this kind of easiness for faculty to bring their things easy to get into students.
Sir, what about you, sir? Like, during your student life, how was it when if some professors call you on the stage?
So, I mean, the funny part was I was a first bench student scoring like a last bench student. So the second, the second question was the first day I took class. The funny part was right after my engineering was over, I started teaching. And the first day I went to the class, in that class, 5 of them were my classmates who had got airbag. So, there was a ragging session for me and the class, so it was a very difficult situation to handle. So that's about how the teaching started off.
One last question, sir. Who was more nervous during your first Viva as a teacher? Or like you or the student? Like when you're asking. Or the student?
Viva, you mean to say this Viva?
Like lab Vivas or project Vivas?
I couldn't actually get. First Viva.
I just want to share an experience. See, when you do PhD, virtually consider the expert on that area in the world. Even your own advisor will not know as much as you have done in the problem. So, because of which, in my PhD thesis, it so happened that the night before the Viva, when I was going through the material, I found a major mistake. Big mistake. Because that happened because I didn't understand the phenomenon of mass transfer. But next day the Viva already fixed, guide is there, examiners, everybody is there. What to do? I presented as I had prepared. And nobody asked me any question about that problem. After the Viva was over, I went and told my advisor there is a big mistake in this. I understood only now. I said, okay, quietly change all the graphs which were affected by that mistake. So I almost read it 28% of the results again. So what this shows is that as you keep working for years, 3 years, 4 years, 5 years, in the entire world you may be the only person who has looked at that problem. Even if you make a mistake, people cannot find it. Alright? So what it means is that, but you have to be at it all the time, you have to be truthful. To admit that I have made a mistake. I know this is a mistake that I have done. So you have to correct it sometimes. So the first experience, knowing that in a big exam that what you have done is wrong. You have to admit it and then correct it. There is always even if you are wrong in the first Viva, doesn't matter, there is a time to correct. If I go to the class and make a mistake, couldn't find it, okay, alright, maybe you're part of it. Tomorrow I'll come and explain to you better. That's it.
So I actually have a very specific instance to share. I don't know if anyone else has had a course of this kind. During our undergrad, we had a course called as a comprehensive Viva exam. And this was not for the PhD level, it was for the UG level, and in the final semester, there used to be, I think, At that time, the number of credits were huge. Each course was easily 5 or 6 credits worth. And I think this was pretty significant. I don't recall the number of credits. So you had to, there would be an examiner and you will have to face questions from any topic till that point, right from the first year. Meaning you could be asked questions on electrical machines, you could have questions from fluid mechanics, thermodynamics, fluid machinery, power plant engineering, it could be from refrigeration, air conditioning, anything under the sun in some sense, not under the sun, but at least or what you have learned over the 4 years. So that was one exam which I was quite nervous with because, see, if you consider any other semester examination or sessional assessment exam, the portion you cover is not so significant that you are so nervous. But this one is everything that you have studied, and so that was a point where I was quite nervous. But then again, it's also true that no one can be very knowledgeable in everything. And the examiner will also not be so very knowledgeable on all aspects. So you do eventually pass, and I got a good enough grade. It was not great, but I have always been an average student, so I sort of empathize with average students. The point is not about whether you are nervous or not, whether you put in a very honest effort is what is important.
Thank you all. Sorry, sir.
I think now we are having the comfort of taking the weather from the same faculty who is teaching. But I did from the university system, the experts are used to come from the university and talking about the BTech. Right? So first of all, you don't know who is going to come or what he is going to ask, whether he is going to ask the questions from the subject what you have studied or the concept what you have studied. So that time it used to be very nervous, and then I used to face and difficulty to get through the questions. But nowadays you are at a different level of different system.
Thank you to all our professors and sir for those thoughtful gestures. Your support and encouragement truly inspire, like keeping us from learning and growing further. So with that, we conclude today's formal program. A heartfelt thank you to our faculty, our keynote speaker, and all the students making this event a success. Round of applause.